Hi all, in this video we will be discussing some few more problems on wave equation. The points of a trisection of a string are pulled aside through the same distance on opposite sides of the position of equilibrium and the string is released from rest. Derive an expression for the displacement of the string at subsequent time and show that the midpoint of the string always remains at rest. Now let us consider a string of length L with vertex OA at the endpoints. Now O has vertex 0, 0, A has vertex L0 because L is the length of the string. Now consider two points B and C as the trisection of a string OA, and B has vertex L by 3, 0, C has vertex 2L by 3, 0. Now pull B in the upward direction of distance A and then pull C in the opposite direction like mentioned in the question, but of same distance, so we can take it as minus A. Now the red color string is now in this form. Now we got two vertices, say B dash and C dash, with vertex L by 3A, 2L by 3 minus A. Now we are going to find the equation of this string. This is the initial form of the string, that is O B dash C dash A. This is the initial form of the string. We are going to find out this equation one by one. Say we find OB dash and then B dash C dash and then C dash A. The equation of OB dash is y is equal to 3A by Lx. Now let me take you back to the slide of how we have obtained this equation. The equation of OB dash with endpoint 0, 0, L by 3A is obtained using this formula. It is called two-point formula. So here x1, y1 is taken as 0, 0, x2, y2 is taken as L by 3A. Upon substituting and then simplifying that further, we get this equation. Now let me take you back to the same problem. Now we are going to find the equation of B dash C dash with these two vertices. This is how the equation appears. Now let me take you back to the slide where the derivation is done. The equation is obtained using the two-point formula. Here x1, y1 is taken as these points, x2, y2 is taken as these points, and then upon substituting and then simplifying further, you can pause the video and then go through the step according to your own pace. Now let me take you back to the previous slide. Now we have obtained the equation of B dash C dash. Similarly, we find equation of C dash A with these two vertices. This is the equation. I will take you back to the slide where the derivation is done. We have used the same two-point formula for finding the equation of C dash A. Now since we have obtained the equation of the string initially, we are going to write down the boundary conditions. You know that at the end points, say when x is 0 and x is L, the displacement is 0, y is equal to 0. And the initial condition is, this is the initial form of the string, along OB dash, this is the equation, y of x is 0, this is the equation, along B dash C dash, this is the equation, along C dash A, this is the equation. Now you know that since initial velocity is not given, we have to take initial velocity as 0. We know the solution of one-dimensional wave equation when we have the initial velocity as 0. This is the solution where an is obtained using the half-range Fourier sine series. Now I am going to find out this coefficient an and then substitute in this equation to get the displacement of the string. We have written the equation of an, and then you know that the string 0 to L is divided into three parts. Let me take you back to the diagram. 0 to L is divided into three parts, that is 0 to L by 3, L by 3 to 2L by 3 and 2L by 3 to L. Thus we are going to integrate this 0 to L into three parts, and then we are going to substitute y of x is 0 according to those intervals. Now Take the constants outside. Here 3a by L, 3a by L and 3a by L is common throughout. So I take that outside and call this as equation number 1. We are going to evaluate this equation step by step. You can call this as first integration I1, this is second integration I2, this is third integration I3. Upon finding all I1, I2 and I3, substitute in this equation. Consider the first integration. Here we have used Bernoulli rule of integration because we have a polynomial here. Here x denotes the polynomial. Now we will exactly mention what is the Bernoulli rule. When you have a polynomial inside the integration, here u is the polynomial, what you have to do is, you have to make sure the formula has alternative signs, that is minus, plus, minus. And in the first bracket you have to write the polynomial. Here u is the polynomial, write u in the first bracket, and in the second bracket you have to integrate this function v. So v1 denotes the integration of v. Once you have obtained these two brackets, the next term will be differentiation of first bracket, what is u dash, and the second bracket will be the integration of the second bracket, that is v2. Now again differentiate this first bracket, integrate this second bracket, so you get u double dash v3. Again differentiate this first bracket and integrate the second bracket, so you get u triple dash v4 plus so on. This is the Bernoulli rule of integration. Now let me take you back to the problem, and then once you have integrated, you have to substitute the limits and then simplify further. You obtained this final equation. Now let us proceed solving the second integration I2. Consider the second integration. Here also L minus 2x is the polynomial. So write the polynomial in the first bracket and integrate the second function, that will be in the second bracket, minus differentiate the first bracket, integrate the second bracket, and then you have to substitute the limits, simplify further. You can pause the video and then go through the steps accordingly. Simplify further, you get this equation. Now we proceed to third integral. Consider the third integral. Here also x minus L is the polynomial. Apply Bernoulli rule of integration, apply the limits, and then you get this equation. Once you get all I1, I2, I3, substitute in this equation, so you will get this expression. Now consider the square bracket. Here the square bracket has two values when n is even and when n is odd. When n is odd number, you will get minus 1. And 1 minus 1 is 0. When n is even number, you will get 1. So 1 plus 1 will be 2. So this an has two different answers. When n is odd, you get 0. When n is even, you get 36. How you got 36? It is 18 into 2. You get 36. And thus let us take n as 2m. Substitute n as 2m in this equation. You get this answer. Since we have got an, now we are going to substitute in our solution. This is the solution of one-dimensional wave equation. Substitute an here, but make sure you have to replace n as 2m. After substituting this is the answer. You can take the constants outside. Na by pi square is constant, take that outside. M is the variable here, so you should make sure you write m inside the bracket. But this is the equation of the displacement. The problem is not yet over. We have to find the displacement at the midpoint. So take x as L by 2. L by 2 is the midpoint. So when you replace x as L by 2, this 2 and 2 gets cancelled. So you get sin m pi. You know sin m pi is 0. So you get the displacement as 0 at the midpoint. So the displacement of the midpoint of the string is 0 for all values of time t. Thus the midpoint of the string always remains at rest. I hope you have understood this problem. Thank you.